OpenAI's next major model, Astra, just solved 10 major problems in maths and computer science, and people have been genuinely impressed with the results, some saying the model is now beyond the intelligence of a PhD. They published the whole thing online for anyone to read, and there's a 249-page paper with 62 pages of the model's own reasoning. But what does this mean for us software engineers? Because from everything we know so far, Astra is built to work on a single problem for days or hours. So if you fancy rewriting everything in Rust, I'm looking at you, Bun, this might be the model you need. So in this video, we'll go through what OpenAI actually claimed and how you can check this yourself and how a model like this runs on a problem for days without getting lost. So first, what did OpenAI actually claim? They put out a post on the weekend titled 10 Advances in Mathematics and Theoretical Computer Science. The results were all achieved by an internal version of Astra, which is their next major model. And they list all 10 of the problems that they solved, which I'm not going to pretend to understand. But they didn't just make the claim. Every result was written out in something called Lean, which is a proof language a computer checks line by line. So you don't have to trust OpenAI, and you don't even have to understand the maths, because if the thing compiles, then that means the proof holds. And they also released the model's own narration of how it got to each of the results. So if you fancy reading a 62-page PDF, then go ahead. And they've got a good reason to be careful, because they got burned on exactly this last October. OpenAI's Kevin Weil put out a post saying GPT-5 had found solutions to 10 previously unsolved Erdős problems, and it turned out GPT-5 had just found papers where humans had already solved them. So they're making a similar claim now, but this time they're being much more careful, and you can actually check the results yourself. It's the same thing we do with code. You don't just trust that a function works because someone tells you it does, at least not all of us. You write a test and let the machine decide. Lean is the same idea, and the compiler either accepts the proof or it doesn't. They also mentioned that the total number of tokens needed to find a solution to these problems would cost roughly 2,000 on sole API rates, which is shockingly low in my opinion. If we keep going at this rate, I don't see how intelligence doesn't just become a cheap commodity. Though that number only covers the runs that actually worked. We've got no idea how many attempts came before them, whether it was one shot or 1,000. And since the model is internal, there's nobody outside of OpenAI who can go back and check. So the 10 results are real and anyone can verify them, but the price tag is up in the air. And if you enjoy staying up to date with AI news, then subscribe to BetterStack. So what actually is Astra? It's likely a new family of models sat next to Luna, Terra, and Sol, but it's aimed somewhere else. The existing models can do our day-to-day software engineering, and Astra is designed for long horizon tasks. And the rumors line up with earlier statements from OpenAI. Their chief scientist, Jakub Puchacki, went on the company's own podcast last year and talked about wanting systems that can work on problems for hours or days, because right now models are good at short tasks, and that's the thing they want to change. So this is a model that could potentially perform research that is completely impractical for humans, synthesizing huge amounts of data and thinking through problems for days on end. But the thing that breaks over a long run isn't always intelligence, it's often coherence. You probably felt this yourself. You start a session with a clear plan, and 40 minutes later, the context is full and the early decisions have scrolled off the back. And then the model is just confidently repeating the same mistakes it got wrong 20 minutes ago. And this is why an open maths problem is such a good test. You can't brute force it and you can't cheat, because there's no partial credit and no feedback until the whole argument holds together. So if a system can stay pointed at one of those for hours without drifting, it can probably be pointed at your refactor as well. But this is the bit that I find really interesting, because a lot of the gain here is coming from the harness and the tools around the model rather than just the model itself. The reported architecture for this is a root agent that creates subagents and hands each a portion of the problem, waits for the results and synthesizes them into a final answer. Now, there's a lot of complexity in coordinating those agents. It's not just a case of hand it a problem and wait for a result. And we've already seen a similar architecture already shipped, because Sol Ultra does the same thing. And with Sol Ultra, the subagents can actually talk to each other when they're doing work rather than just remaining in complete isolation. But splitting a problem up isn't actually free. Every time you hand work to a subagent, you pay for it in coordination, because multiple agent setups can do worse on tightly coupled work like planning, where the overhead and the compounding errors wipe out whatever you gained by splitting up the work in the first place. The whole design hangs on the fact that splitting a problem up and then stitching it back together buys you more results than the coordination actually costs. On these 10 problems, the results clearly paid off, but we can't just trust internal results. So we'll have to wait to see how this turns out when we can get our hands on it. Now, of course, there's a lot of talk saying this is now replacing mathematicians, and Thomas Bloom pushed back on that. He said it's not right to call proving one conjecture made by a mathematician using theories developed by over a century of work by mathematicians with an AI built by mathematicians and trained by reading everything ever written by all mathematicians as replacing mathematicians. So the replacement argument looks weak to me, even if the results look promising. But it'll be really interesting to finally get my own hands on Astra and try it out myself and see how practical it is for software engineering tasks. But I hope you enjoyed that one, guys, and if you enjoy staying up to date on tech and AI news, then subscribe to BetterStack. Otherwise, thank you so much for watching, and I'll see you in the next one.